So this video is going to go through the instructions on how to name compounds. Make sure before you watch this that you have a solid understanding of ionic and molecular bonding and understand the difference between the two. Alright, so we're going to start off with naming ionic compounds. So in this scenario you would get a formula and you would be asked to come up with the name for that compound, okay? Now, you're usually not told whether it's ionic or molecular. You need to be able to tell that by yourself. And you can just do that by looking at the periodic table. Remember that ionic compounds form between metals and nonmetals, whereas molecular compounds form between two nonmetals. So in this case we have a metal, which is sodium on the left, and chlorine, a nonmetal, on the right. So if we have a formula like this, we come up with its name by following these steps. So first, we're going to write down the name of the metallic element. And we always write the metallic element first. Okay, so sodium. Next, you're going to write the name of the non-metallic element after that. So I start this, except I'm changing its ending to "ide." Okay, so instead of sodium chlorine, I'm going to change it to sodium chloride. Okay, you put those names together, and that's how we come up with the name. So NaCl, the chemical name for that, is sodium chloride. So something else that I should note before we move on is that IUPAC states that when you are writing out a chemical name, you use all lowercase letters. So that's why no uppercase S, no uppercase C. When we're writing out the chemical name, it's all lowercase. Our uppercase letters are only used when we're using them in symbols. So when we're using chemical formulas, of course, we use uppercase letters, but for the names, no uppercase. Alright, let's try another one. So this time we're going to be getting that compound to come up with a name. KBr is, of course, also an ionic compound, so there's a metal and there's a non-metal in there. So in order to come up with a name for this, I'm going to write the metallic element's name first. In this case it is potassium, so I'll write that all lowercase. Okay, I'm going to write the non-metallic element, and I'm going to change the ending to "ide." So instead of bromine, it's bromide. And we'll do one more for good measure. So this time, let's do Li2O. Our first element is our metallic element. In this case, it is lithium. Okay, and then we'll write the second element. Now in this case, oxygen changes to oxide. So lithium oxide. Now, regardless of whether there are the little numbers beside them or not, in terms of ionic compounds, it doesn't change how we write the name. Okay, that will be different from molecular, but for this, it doesn't change how we write the name. Now we're going to go from a name to a formula for ionic compounds, which is a bit of a trickier procedure to go through. So for a question like this, you would get a name, something like this, lithium oxide. And you need to come up with a formula for it. So let's just go through the steps slowly on this. So the first step is to just list the symbols of the first element and the second element. So lithium, the symbol is Li. Oxide, that's oxygen, the symbol is O. Okay. The next step is kind of where it gets a little bit trickier. We need to look for the charge of each element based on where it falls in the periodic table. So the different elements in the periodic table will form different ions with different charges. And the chemical families, which are the groups up and down the columns of the periodic table, will form similarly charged ions. Okay, so based on where it is in the periodic table, which indicates how many electrons it has in its outer shells, that's how you're able to determine what charge it is. But there's a pattern, luckily, which you do need to remember and should help you through doing this. So let's start over here on the right with the noble gases, which do not form ions. They're happy with the electrons they have. They don't want more. They don't want to give any up. The halogens right next to it form 1 minus they form 1 minus ions. The group right next to it, 2 minus. Next to it, 3 minus. Okay, then we'll start from the left side. The alkali metals form 1 plus, alkaline earth metals 2 plus, then we jump over to here. These are 3 plus, leaving this kind of one column in there with carbon, which could kind of go either way, 4 plus, 4 minus, it's the same thing, okay? But in the end, carbon doesn't really form ions, okay? So this is kind of as much as you'll need to know. So once you can kind of determine that, you're going to write the charge of these ions next to it. So lithium, because it is from the alkali metals, lithium will form a 1 plus ion. So just a plus there. Oxygen over here will form a 2 minus ion. Okay, so I've listed them, I have their charges. Now I'm going to go to step 3. Because now I need these to combine in a ratio that makes a neutral compound. Okay, obviously I can't just put one lithium and one oxygen together because that would not neutralize each other. Okay, so I have up here the crisscross rule to help you remember this. So in order to use the crisscross rule, you look at the numbers that are in the charge, and that number in the charge becomes the numbers that indicate how much of the other element there is in the compound. So you crisscross those numbers. So LiO, I'm going to write this again. I'm going to take the 2 from up here, it's going to go down here, so Li2, and I'm going to take the 1 from up there, it's going to go down here, and well, I don't need to put a 1 because we don't need to, so Li2O is going to be the correct answer for that. Alright, we'll try one more, or another example. This time I'll do lithium bromide. So first I'm going to just write down the element names and determine their charges based on where they are in the periodic table. So again, I'm just looking for which column of the periodic table they're in, which family they're a part of. Okay, lithium is an alkali metal. Alkali metals are in that first column on the left, and they're really eager to get rid of their extra electrons, so they easily form 1 plus ions. And bromine is a halogen. They easily form 1 minus ions. Okay. Alright, so crisscross rule, I will rewrite these, and if necessary, write the numbers down there. But in this case, we have the equal amount of positive and negative charge. We have a 1 plus and a 1 minus, so they can combine in a 1-to-1 ratio, and we don't actually need to add any numbers. LiBr is the correct answer. Alright, one last example for this process. Aluminum oxide. Aluminum oxide. Aluminum is Al. Oxide is oxygen. O, the charges based on the column. So aluminum is in the third column from the left. It forms a 3 plus ion. Oxygen is from the third column from the right. It forms a 2 minus ion. Okay, using the crisscross rule, go Al, O down here. I'm going to take this 3, I'm going to put it down here, take this 2 and put it down there. Make sure you're just copying the numbers down there, not actually the charges. I don't want to see Al with a little minus down there or a little 3 plus. Okay, we just want the number value, not the charge. So Al2O3. Alright, so now we'll try doing some naming for molecular compounds. Remember that molecular compounds are compounds that are formed between 2 nonmetals. So the first example that I'm going to do is for CO2. Okay, so we're just going to follow the steps here. So first we're going to write the entire name of the first element and the second element. So I'm going to go carbon, and then the second step it says to change the ending of the second element to "ide," like we were with ionic compounds. So we have carbon oxide. That's what we're going to start off with. Then we get to this third step, using a prefix to indicate the number of each atom in the formula. So this is new. Molecular compounds use these prefixes that I've indicated up here in this table. And what a prefix is it's something that can be added onto the beginning of a word, and it can indicate something. And these are all kind of based on Greek. So for carbon, for example, if we look up at the formula, there's only one atom of carbon there, so it means we're going to use this first prefix, mono, and there's 2 atoms of oxygen, which means that I need the second prefix, di. Okay, so that's all good, except I see that this last rule is there, and it's actually an exception to the rule. So for this mono thing, we only use mono if it's for the second element. We don't actually use it if it's on the first. So in the end, this is not needed. So just carbon dioxide is going to be the name for CO2. All right, we're going to try another example, and this time we're going to do IF. So just going through the steps. First things first, you got to identify which elements those symbols represent and write down their names. In this case, it's iodine and fluoride, changing the ending of fluorine to "ide." Okay, and then we need to put the prefixes in. So for both of these atoms, there's only one atom of that element in the compound, which is indicated by the formula, and so then we can look for the Greek prefix that means 1, okay, which is mono. So monoiodine, monofluoride, except that there is an exception to the rule. We don't use mono for the first element, so I'm going to leave out the mono there. I'm going to add the mono in here. So iodine, monofluoride. All right, one more example. This one is going to be H2S. So first things first, I'm going to write down the names of the 2 compounds, hydrogen and sulfur. I'm changing the ending to "ide." So hydrogen sulfide. I need to use my prefixes, or I need to look at my formula to figure out how many atoms of each element are in this compound and use my prefixes to indicate that in the name. So in this case, we got dihydrogen monosulfide. Dihydrogen monosulfide. A little bit messy, but there it is, dihydrogen monosulfide. All right, now let's talk about how to go the other way with molecular compounds, so taking a name and going to a formula. And you'll find that this one's pretty easy. Okay, so I'll just get an example done and we'll go through the instructions together. So for this one, let's start with a compound that we know, dihydrogen monoxide. Okay, and let's just break down kind of those steps. So first, you're going to list the symbol for the first element and the symbol for the second element. So here we have hydrogen there, and oxide, that's going to be oxygen. Okay, so H and O are our 2 symbols. Then we're looking at the prefixes, and we are trying to determine what number that means. So di right there means that this is an H2. Mono right there means that this is an H, or this is an O1, which means we don't need to put any number there. Okay, dihydrogen monoxide becomes H2O. All right, so the next example we're going to do is carbon tetrafluoride. Okay, so I see carbon there, I see fluor there. Remember that the ending of that second compound, or second element, has been changed to "ide, so you kind of need to work back for that. So that's fluorine there. So we have C and F. Okay, carbon has no prefix, which means that there's just one, and fluorine has tetra as a prefix, which is 4. It's a CF4. And one last example. This one will be diphosphorus trioxide. Okay, I see phosphorus there. The symbol for phosphorus is P. Ox over there is going to be O. Phosphorus has a di in front of it, P2. Oxygen has a tri, P2O3.